Welcome to Homework Lib.
Chapter 14, question 110. The following mechanism has been proposed for a gas phase reaction of chloroform and chlorine. Now, what's the overall reaction? So to be able to do that, I want to add all these three steps and left-hand sides to the left-hand sides, right-hand sides to the right-hand sides. So let's start. Cl2 plus Cl plus CHCl3 plus Cl plus CCl3. These are all left-hand sides. And the right-hand sides, 2Cl plus HCl plus CCl3 plus CCl4. Now, if you want to rearrange these, what we have is CCl3 over here, is CCl3 over here, so they cancel. Do we have CCl4? We don't. Do we have HCl? We don't. We have 2Cl on the right-hand side, and we have 2Cl on the left-hand side. So they cancel too. So overall, what we're going to get is Cl2 plus CHCl3 would go to HCl plus CCl4. Now, what are the intermediates in the mechanism? So the intermediates are each elementary step, we get something at the products, and if that whatever we get in the products is consumed in the other elementary step, that is an intermediate. So chlorines over here are the intermediates, since we get them in the products and we consume them later on. Over here, we get a CCl3 over here in the products, and we consume that too. So CCl3 is also an intermediate. So this was part A, and part B would be CCl3 and Cl. Part C, what is the molecularity of each of the elementary reactions? So the molecularity of this first one is going to be unimolecular. The reason why is this is only one molecule. And the second one is going to be, there are two molecules, so this is going to be bimolecular. And third one, again, two molecules, so bimolecular. At D, what is the rate determining step? The rate determining step is always the slow step. So you need to think about that as if you have a group of people and if you have your grandma with the group, even though you're faster than your grandma, you need to walk with your grandma. So she is determining the entire group's speed. Hence, the slow speed is going to be the rate determining. At E, they're asking us, what is the rate law predicted by this mechanism? So normally I would write the slow steps rate law, which would be K Cl CH Cl3. However, I cannot write that. The reason is Cl is an intermediate. So I need to get rid of the Cl's because we don't see Cl at any rate in the reaction. They do not appear to us. What appears us is what we start with and the overall reaction over here. So let's just try to get rid of the Cl. How we can do that is to look at the step 1. Over there we have K1 times Cl2 would be equal to K minus 1, the reverse reaction, Cl to the power of 2, since there's a 2 over here. So if I want to write Cl in terms of something else, then what I can write is K1 over K minus 1, and this Cl2, everything is going to be square rooted to get rid of this power of 2. Instead of writing K1 and K minus 1 and all these Ks, I'm just going to collect all the Ks in a common term, K. So if I write this again, this is going to be K times, instead of Cl, now we can write Cl2 to the power of 1 over 2 and CHCl3. And this goes along with the hint the overall reaction order is not an integer because we have 1 over 2 and 1 over here.